get started and other people trickle in. So, are we recording? So just to quickly introduce myself to everybody, my name is Keith Battocchi. I'm actually a contractor working for Don Simon in Microsoft Research. I am working on various little things around building better support for using F-sharp with big data and other things in the enterprise. And what I want to talk to you about today is putting F-sharp to work for you, and specifically, I think there are a lot of people at previous talks I've given who say, F-sharp looks like a great language. I totally see why people might want to use it. Maybe if I have a side project I think of in a couple months, I'll definitely use it for that. But it's a little bit harder sometimes to see, how can I use F-sharp maybe even in a professional context. There are people who say, I'm tired of using C# on the job, but we can't switch over to F-sharp wholeheartedly. And I want to give you a couple ideas of things you can do to incorporate F-sharp more in your day-to-day lives. For those of you who are using F-sharp day-to-day, hopefully there will be little things here and there that you might not know that will be a benefit to you as well. So just as a brief outline of what I'm going to talk about, again, the premise of the talk has kind of two parts. The first part is that F-sharp is an awesome language. I think it's really a terrific language. It's both extremely powerful, but also very fun to use. So, I don't know how many of you use, C# template metaprogramming or things like that a lot. That's very, very powerful, but I don't find that very fun to use. I think F# strikes a much better balance where, on the one hand, you can do things that are really hard to do in other languages, but at the same time, it's still very readable. It's still, your code really looks nice. It's enjoyable to type. And I'll talk very briefly about how F# is going to get even better in the next release. I don't want to focus on that. I know Don Simon gave a talk about type providers either the last month or the month before. I'll talk a little bit about it, but that's sort of just an additional point. The second thing I want to cover is you should be using F#. Pretty much whatever you're doing, there are ways that you can be using F# day to day, and it will make your life better. Again, I'm not suggesting that necessarily it's going to be the only language you use or anything like that, but I think really there are ways that you can incorporate it in your day-to-day development, and you will feel happy that you have done so. So again, there are lots of different ways to get started. It's just one more tool for your toolbox. It's not going to be the only thing you ever use, and it will prepare you for tomorrow's challenges. So again, when I talk about the type providers and things like that, you'll see that there are some things that the next version of F# is going to allow you to do that really I don't think there's anything comparable out there. So what's so great about F#? I think one thing that almost everyone's talk on F# always includes is simple code to solve complex problems. I think that's very true. And there are a couple of different things that go into that, which I'll talk about in a bit. One of the things that I really appreciate about F# is it scales all the way up from doing little one-off interactive scripting tasks all the way up to building a complete application or a web service or whatever you might want to be doing. And so I think it's pretty rare that you get things that are really easy to use on both of those sort of scales. If you look at something like C#, it's I think C# is a great language, but if you're doing sort of a little one-off task, it's pretty annoying to have to go in there, create classes, get your main method set up. It's really not at all able to do that sort of scripting stuff that you might want to do. On the other hand, I think a lot of people have experiences where they use a scripting language like Perl or Python or Ruby, and they find that for building a small application, a little website that's not getting a lot of traffic, that works great. But as you start to scale up and as more and more people start hitting on things, then stuff starts to break down. I think F# actually really is able to range the whole gamut there. Another thing that's fantastic about F# is it's got great .NET interop. So if there are people who are using C# right now, if there are people who are not using C# but they're thinking about it, they know a couple libraries that have been released and they want to sort of play around with them to see what they're like, F# will allow you to interoperate with that code really nicely. And right along with that, F# is now a part of the Visual Studio product. I think that's really a huge benefit. That's, first of all, I think a great step on Microsoft's part to really push the language out and get more adoption. But anybody who installs the full version of Visual Studio will have F# on their computer, and I think that's terrific. Makes it a lot easier to get started using it. And then finally, depending on what you're doing, F# already has really terrific support for parallelization and asynchrony. I don't know how many people are familiar with the asynchronous features that are being built into the next version of C#, but those are already in F#. There are a lot of reasons that people maybe want to use F# for really performance-intensive things where you've got either asynchrony that you're dealing with on the server side or on the client, or where you need to do things involving parallelization. So, going back to simple code. So what makes F-sharp code so simple? So I think one of the things that's really terrific is there's pervasive type inference. So what I said is it looks as clean as Python, right? You don't have type declarations all over the place. You have this very nice white space sensitive language that really reads almost like pseudocode, but you get IntelliSense. The types are there, you're just not typing them in. And so the compiler is going in there and figuring out for every expression in your program, there is a type that expression has, and the compiler knows what it is, and it can give you great IntelliSense. You get all the other benefits of good performance and all the other things that you think of with strong typing, but you don't have to deal with all the sort of syntactic cruft. And then right along those lines, bless you, there's readable syntax for a lot of really commonly used types. So functions, tuples, lists, arrays, whatever it is, all those types that you use day to day. There's a really short, readable way to write code that uses them. And then finally, one thing that's really nice that is somewhat unique to F-sharp is there's the concept of computation expressions. So that's really beneficial if you're writing things like sequence generation, or you're doing asynchronous computations, or there may be things where you're writing your own computation builder to do things that you care about. And again, it's all about making it so that you can write code that you can read through really easily, but that does sort of complex things in the background in an understandable way. So that's all I'm going to talk about in terms of why F-sharp is so awesome. And for the rest of the talk, I want to talk about how you can start using F-sharp. And I'll show a couple demos in a bit, and so you'll see some of the things that, the code really does look simple. You can see how powerful it is, but I'm not going to really explicitly talk about that anymore. So here I've got 4 different sort of increasingly intensive ways that you can use F-sharp in a professional context or at home, whatever you may be doing. So one thing that I use it for is just simple math. If you've got calculations that you want to do, rather than firing up calculator, just have an F-sharp interactive session running and type in your calculations. I don't know what types of things people do, but even for figuring out how many hours I worked in a given week or something like that, it can be helpful to be able to assign identifiers to say, okay, in March this is how many hours I worked, in April this is how many, add them all up and multiply by the billing rate or whatever you may be doing. I think this is a really small thing, but if you want to really ease into starting to use F-sharp, just have an F-sharp window open at all times on your computer. When you think of something you want to calculate, type it in. A little bit more intensive use is what I'm calling investigation, but I think it covers a whole bunch of different things. And this is really all about using F-sharp interactive to help you in your day-to-day tasks. So one thing that you can do is explore .NET APIs in an interactive way. So there may be, like I said, a library out there that you want to play around with, and you're thinking, what happens if I start using this function? What happens if I use that function? How do things sort of really work? Another thing that you can do is debug or test your own code. So even if you're writing your code in a language like C#, you compile it, you get a .NET DLL out of the end or an executable. You can then use F# to go in and debug that code. And I think in a lot of cases that's a lot more productive than it would be to use C#, go into the debugger, step through line by line, maybe figure out you want to watch something, so you add a watch, but it's pretty tedious to have to step through. What if you want to change something? Then you have to really recompile and start that whole cycle over again. In F# Interactive, type in a function definition, execute it, you immediately get the answers, make little tweaks, execute it again, see what happens. It's really easy to see if things are working the way they ought to be. One level up from even that would be prototyping using F#. So at that stage, you're really using F# and writing entire algorithms in F#. So again, it's great that you can use the REPL to read about print loop, which is the F# interactive component. You can really interactively build applications all the way from the ground up. They can have all the things that you would have in a normal compiled application. They can have GUI bits. They can have the sort of algorithms running in the back, whatever you want to do. And you can even do web services, etc. And so I think there are many things, all that sort of simple code stuff that I was talking about earlier really makes it pleasant to do prototyping in F#. That doesn't mean that you need to then take that F# code and build it into your product. You might be able to then step back and say, okay, that was a great proof of concept. Now I'm going to go re-implement things in C# or whatever other language you may be using. And then finally, For some people, I think it's appropriate to be doing all of your development in F# or a major part of your development in F#. So the idea there would be, you're using F# day to day to do most of your programming. You're compiling it, you're deploying it internally, externally, whatever you may be doing. And I think there are cases where that's a huge win, right? If you want to write really sort of math-intensive code, doing it in a language like C# is less pleasant and in some cases less performant than it is in F#. And so I think doing it in F# makes a lot of sense. And there are reasons you might not want to do things in F#, like there's a huge learning curve, so depending on how many people are on your team, it may not make sense to say everybody on our group is going to switch over to using F# to do all our development. But the more that you're doing things where the benefit of F# over a language like C# is so huge, the more it's going to make sense to really switch over to F# even for your development. Again, good .NET Interop makes it easy, so you don't have to build everything in F# all at once. You can start with a C# application and replace components bit by bit as you go through and refactor things. And then the interop works both ways, so you can have C# code which relies on F# code, or you can do it the other way around too, where the F# code relies on C# code. It's quite smooth. So, drilling down a little bit further into one of the things I talked about with investigation. So, like I said, you can interactively explore .NET APIs. You can say, what happens if I pass this value into this method? What happens if I execute these sequence of things in a row? If I create a new object, and then I call this method, and then I create another new object, call this other method, what do I get out at the end? If you're just getting started with an API, a lot of times, you just go and you look at the MSDN documentation or the documentation that comes with it. That gives you a pretty good idea of how things should work. But a lot of times there's ambiguity in that, or you see places where it doesn't completely answer exactly what's going to happen in a particular scenario. Really easy to use the F# interactive tool to run through those sorts of scenarios. Again, that's great not only for the .NET-based class library, but if you have commercial libraries that are written in .NET you want to use, you can even use F# interactive to do unmanaged interop, but that's a little bit more advanced and a little bit more painful in some instances, so a little bit more advanced. But I think anybody who's doing .NET development can really get a lot of value out of using F# in this manner. And then the other thing I mentioned was debugging and testing your own code. And again, that code does not have to be written in F#, that can be written in any language. And you can even, although this is a little bit tricky and hard to do, and I'll show you how to do this later, you can actually add F# scripts to C# projects in Visual Studio. And so you can save that along with your project. It doesn't get built into your executable, but it makes it really easy for you to go in there and rerun something that you've already ran to see how things work, to make sure that you get the test output you use for that. Finally, not only can you do that locally, but another thing that a lot of people do is they're building web services, things like that. You can test web services from F#, or you can write the web service component in F# and test that in another language. So even if you're doing Java development, you can have Java code that expects to call a web service that returns certain results, implement it in F# or mock it out at least, and see that your Java component works the way you think about it. So I will quickly give you a demo in Visual Studio of a couple of the different things that I just talked about. So let's see. So the first of these is actually based on something that I ran into, and I apologize. Let's try to get more of this stuff on screen here. So the first of these is actually an example of a bug in my program that I found quite a while ago when I was working on something a couple of years ago. And that is, this is just the normal .NET standard base class library. There's this method called HTML attribute encode, which encodes some text so that you can stick it into an attribute of an HTML element. And I was working on building a web application, and when I ran code that looked sort of like this, I got output that I didn't expect. And so, I could use C# to debug that problem, and that's how I found out that this is the place where I would run into issues. But again, using the immediate window in the C when you're debugging C# or going through the whole compile, rebuild, jump to the web page, see if the output is now what I expect it to be. You know, that whole cycle takes time and is really kind of frustrating to deal with. Using F-sharp Interactive enables you to just get right into it, see what the output is, see if you can figure out exactly what's going on. So, what I was expecting to happen, well, this is actually a complicated story. What I was expecting to happen was for these apostrophes to be escaped. Turned out at the time they were not escaped, but I run it now they will be because there was a behavior change in .NET 4 from .NET 2. But anyway, you can take this code, execute it, you see down here the result, and now the quote is being escaped. If you actually look at the documentation here for that method, you'll see that that hasn't made it into MSDN as the documentation for what gets escaped. So again, this is somewhere where you can read the documentation, you can figure out how things are supposed to operate, but once you get into the code, you may realize that, that's not exactly what's going on, and you may want to sort of interactively play around and see, can I get this thing to work the way it ought to? What do I need to do if I have to fix that bug? Similarly, another library that people use all the time is the regular expressions library. So a lot of times you'll have something like, okay, I want to take this regular expression, it's going to find a hash symbol, a bunch of characters in between it, and then another hash symbol, and I want to just identify all the instances of that and see what's in there. And so you might think that that regular expression, if matched against this long string, would identify item 1 and then item 2. If we execute this, you'll see that that's not the case, and so I'm just printing out the first match. You can see that the text in here actually goes from the first hash all the way to the last hash, and so it includes 2 items. Again, common mistake, happens to everybody, but if you have that, have an error like that in an application that you're building, it takes some time to debug. Debugging using something like F-sharp Interactive will really lower the time it takes to do that.
Last questions now?
Yeah, please feel free at any time to interrupt, absolutely.
I would say what would be nice if those scripts, like you can hit some shortcut and run the whole thing can in this text script, not copying it direct, just run.
Sure, I mean, depending on what you want to do, so you can do that. So if you have a script, you can, and you have another script, and you want to run everything from the first script, you can use the load directive. So if I went down here in the bottom and I had this isn't saved right now, but if I had this saved to my hard drive, I could go down here, type hash, load, and then the name of the file, and it will run everything in there.
No, I know, I mean that would be nice if you can just run one file, the one that opened now, I can just do some shortcut and run the whole thing just for this.
You can actually.
How? You can have to copy it in the directive, no?
Well, you're going to run it in interactive.
No, I mean not copying it in the directive, right? So just
well, if you do Control-Alt-Enter, it'll take the whole file and put it into interactive and run it.
I mean, if you have suggestions for features, I'm not the person to talk to, but please feel free to email. No, seriously, please feel free to email fsbugs@microsoft.com.
No, it's
They're very
no,
feature requests as well. The alias is a little confusing. People think it's only for bugs. If you have feature requests, seriously, the team is happy to hear what people find painful with dealing with the language. So, definitely suggest that.
The problem is you suggested that sometimes you want to organize that session, right? Because might affect one hit, might affect another. So after you run first thing, you would like time to reset session, right?
Yeah.
Let's say
I see your point. Yeah, you might want to put it into a separate process. Yeah. Okay.
Yeah. I mean, I think that sounds like a perfectly legitimate use case, and so I would say again, suggest that I suppose.
Another thing I would like to add, like exploring .NET API. So for regular F-sharp functions, you can just type in function in the directive and see type signature, right?
Mm-hmm.
You cannot do it for the
Okay.
You can?
Yeah. So let's see.
Try the static one, which is utility.
So okay. I mean, this is an instance method. So I created a regex. I access the matches member, and it tells me that's a function from string to a collection of matches.
What about static? I mean,
Yeah, static works too. So
I remember I tried it and had some difficulty.
3.0, right?
that I am running a previous version of the compiler. However, I believe that this will work in F-sharp 2. So you should be able to do that and get any method. The only time that doesn't really work is if you have overloaded methods, then sometimes you can't figure out what overload you want.
Yeah, yes, yeah, you're right. Yeah, you're right. It's probably
yeah. So then it's a little trickier. You could either pass in the right parameters or something. There are ways to figure it out, but that is a bit more difficult. Yeah, sorry.
You're not talking about the benefits of F-sharp. It's basically F-sharp interactive.
Well, I mean, yes and no, right? So yes, I think if C# had a C# interactive, that would make C# a lot better to use for this sort of thing. And so I find that a huge benefit. But there are other advantages also.
Take a look at LinkPad.
Yeah, I mean, there are things out there that will enable you to use C# interactively in some settings, but I think there are inherent limitations to C# that make it harder to do some of this stuff than with F#. And there are cases where, maybe calling a single method, it wouldn't be that bad, but in F# interactive, you can define a whole type, you can define, you can define modules, execute it all, and get the results out of them here. And I think some of that stuff, the way F# is designed as a language is just more amenable to running interactively than C#. There is also a mono C# interactive REPL of some sort. But I think in general, the built-in tools within Visual Studio to get this stuff done are fantastic for F#. But I think also, listen, it's true that a lot of this, the things that I've been talking about is down to the fact that there is a REPL for F#. There are lots of other advantages of F#, and all of those still come into play in this scenario. So in this case, okay, we're just calling a method. That looks pretty simple in whatever language, there's not a language out there that makes you write 50 lines to execute a single method. But if you want to have a little bit more complicated logic, then all of a sudden, that F# code's going to look a lot simpler than C# code, even if you want to run it interactive or not.
Even here, you're not going to see that nice picture of what's inside your object if you just execute it in C#, right?
Yeah, you're right. So I mean, but someone could maybe build that. I don't want to say it's impossible, but what you get out of the box with F# I think is really great for doing.
This was actually LinkPad does. It does some things behind some things behind the scenes for you. It's like they have this dump extension method which you can attach to enumerables, and then you're going to see what exactly you're getting.
Yeah, but that gets really crazy if you have anything that's disposable. I mean, I've ran into situations with that before.
Yeah.
I was going to say, I wrote the thing for the user group as I just have to jam out a script to scrape the users that are coming to Microsoft Security, and it's 6 lines of code, and I just I run the first half and I check the count to make sure it matches the count on the web page, and then I export it to a CSV and load it and sell it. It just took a couple minutes, and that would have taken forever to write this shit.
Yeah. And I mean, I think I also don't want to say, F# is fantastic, C# is horrible, it takes infinitely longer to write something in C#. A lot of times that's not true. But I think as a human being, I find even a savings of a couple minutes really fantastic. It affects my flow when I'm developing. It just is really enjoyable to use F# to do this sort of things. So another thing I want to show is, since I mentioned it, adding an F# script to a C# project. So again, I don't know why it's doing that. So just again, I'm running a pre-release version of the F# 3.0 compiler. So if you notice that things act a little weird, or I get weird, exceptions or things like that, bear that in mind.
The other thing about the long-term interactive scripting thing is, I think, is there's certain economy of effort for for example, for the test you're about with the user group. If you're going to do that in C#, even if it wasn't any more lots of code and much more thought, you have the overhead of got to create a project, it's got to be an executable or a DLL. It's not something where a script, it's a file, you throw it in a notepad, you throw it to the command line, whatever you're doing. You don't have that whole overhead of building and executable.
The whole seeing intermediate values, I mean, I actually run it by using alt enter.
Yeah, absolutely.
Let's make sure things are going right.
Okay, so I just created a new C# project. I'm going to build this something where F# script and access. So again, this is slightly tricky if you want to do it. If you add existing item because you've got an F# script lying around somewhere, that just works. However, if you go to add a new item, there's a little trick here because the C# project system doesn't know anything about the F# different item templates, and so you won't see F# script here. But what you can do is take some file which has pretty reasonable content, like a text file. And if I just go down here and I say FSX, and make sure to give it the FSX extension, and you can also rename it after you add the project, then Visual Studio is smart enough to know that that's actually an F# script. And so, again, if you have an existing C# project and you've been working on it for years, and you want to play around with F# and access your executable and see what does the surface area of my existing project look like from F#, it's really easy to do as long as you remember that sneaky little trick. And so to prove that this actually works, here is the exe. So I think what I can do is actually make a relative reference for so I can reference that executable that was built, and what's the namespace? So it still abides by the accessibility rules. You gotta make that public.
Should make class public as well.
I thought the accessibility for classes was automatically public.
Yeah, I think the
Performance is internal.
So the problem is now that my F# script is accessing it. They won't let me.
What was in it, your interactive access?
I think have it.
You have to reset your interactive session.
That might have worked. I can't remember if I actually sent that to it. But anyway, again, it takes a little more skill than I have anyway. This will work. That works now. And then here. In any case, I don't want to get bogged down in this, but trust me, I've done it before. How you can reference, you can add an F# script, and you can reference the URLs that you go over.
Why do you have to reference it?
Should work now.
Sorry.
Why do you have to reference the assembly?
Because, well, because basically an F# script does not know about the things that are in your project references or in your outputs. So if you have things that you reference, and you got an F# script that you just dropped into a project, you have to reference those assemblies. If there are assemblies that your C# project references, you'd have to add references to those as well if you want to use them.
Okay.
You should know that F# also has like this regular assembly programming
Yeah.
language. You can make assemblies with it and have your project just also supports scripts.
So you now have IntelliSense over it. Active. Call on it, and you have to do anything, but it works. So you can do that in your own projects. Obviously, you've got to tweak a couple things to get it working, but in your own cases, probably most stuff is public, and you won't have to do any of that. But that's a nice little trick that I think is not obvious, but is good to know about. And then one other thing that I had mentioned was web services. So I'm going to run Visual Studio as an administrator and just show a very simple example of doing self-hosted WCF web services in F# Interactive. So I have an existing project here, which is very straightforward, and essentially is really a transliteration to F# or the C# examples on the webget attribute. So this script, we reference these WCF assemblies, open those namespaces. We've got an iCalculator contract, which has some operations on it, so add, subtract, multiply, divide. And this webget method attribute just tells you what the URI is going to look like to access those things, and in some cases what the request or response is going to look like. But there was no reason that I did those the way I did. I just basically copied what was in the MSD example. There's a simple type that implements that interface. And now we can say, let's run an instance of that service on our local machine here. Fire that up, and hopefully I can now go. So now I'll call this tracking up. So I'll try to, I don't know if you can see the whole URL here, but it's just the base URL plus the subtract method call. Ask it what 4 minus 7 is, and you can see that the answer is -3. Not all that amazing, but you can run really, you can really easily host a web service in FSI, and if you want to target that with your C# application because it's expecting some stuff to come back, then you can mock it out in F#. And again, that's another way that you can sort of really quickly get up to speed and use F# to do things a little more quickly than you'd be able to in C#. Again, writing this code itself in C# is not that bad, but then if you go in there and you want to change one thing here, one thing there, you have to go through that whole build, rebuild cycle. Whereas here, you make those changes, send it to F# Interactive, and it's just a lot quicker. Okay. So that was exploring .NET APIs. The next thing I want to talk about just for a little while is prototyping. So again, this is where some more of the benefits, other than just the doing things interactively. Here, the fact that F# code, in a lot of cases, as opposed to C# code, F# code is going to be shorter, it's going to be easier to read, and those aren't always the same. I mean, Perl code is going to be shorter than code written in a lot of other languages, but it's great once, never or whatever. And I think F# really enables you to directly translate algorithms into code. In many cases, you can take pseudocode, and the F# code you get from looking at that looks almost exactly the same as your pseudocode. So I think those are some reasons that F# code is a little nicer. And what that means is if you do your prototyping in F#, it takes less effort. And one of the really nice things is even if you're planning on doing your prototyping in F#, taking that and throwing that away because your company has a policy that everything's written in C# or whatever, one of the big benefits you get out of that is you have a reference implementation as a result of that. And you can therefore test your C# implementation against that. And so I think in a lot of cases, even though you're implementing the thing twice, doing it the first time in F# is going to take less time than it would in C#, and then the additional cost of either transliterating that over or creating a new, faster implementation in C# that does things a little differently or whatever, a lot of that time is going to be, the total time to develop it may be less because the prototype is easy to develop and because you have a reference implementation you can test against it, and you can see, okay, I'm getting different results out of my C# code. Where did things go wrong? It's pretty easy to go step through them both, see, okay, this bit of the C# code is returning something different than this bit of the F# code. So I'll give you just a quick demo, and this is sort of an involved example, so I don't expect people to dig in and get all the details here, but what I wanted to show, so this is something similar to something I did for a client several years ago. They had all their code written in C#, and so I knew that when I delivered code to them, it was going to be written in C#. But in order to make sure that I understood what was going on with this algorithm and I could implement it properly and I was getting the right results, I prototyped it in F#. And so the algorithm that I got here is called the Needleman-Wunsch algorithm for aligning sequences. So this is what's called a global alignment. If you think of DNA sequences, you want to see, are there stretches of bases that are the same in sequence A versus sequence B. The way it does it is through something called dynamic programming. Again, I don't want to get into all the details. Here is basically the way the algorithm works. We get a couple of sequences in that we want to compare. We get a scoring function that tells us, given this base in the first sequence and this base in the second sequence, if I end up aligning those next to each other, is that good or bad? What's the penalty there, basically? There's a gap penalty saying, okay, if I actually split the second sequence and I have a base here, match it against nothing because I matched the first half somewhere else and the second half somewhere else, then what's the penalty for that? And you basically go through and you calculate sort of, if I match up to a certain point of the first sequence with up to a certain point in the second sequence, what's the lowest cost way I can do that? And then based on that, you can sort of recursively figure out, okay, then if I step one more in each direction, what's the lowest cost way to do that? So I won't go into all the hairy details of this algorithm, but you can see that overall, the whole thing is about, what does that say, 27 lines. If we go look at the Wikipedia page for the algorithm, then we've got the first half here, where we're going through, we've got 3 for loops, and then we've got this whole alignment part down here. You can see that actually the F# code is about the same length as the pseudocode, but the F# code actually works. And so we can go in here, execute this, and the F# code, again, isn't littered with type declarations everywhere and things. You know, it looks a lot like the pseudocode does. We have, you know, we're creating arrays, and it's obvious from the context, we cover over them. Okay, actually this alignment function is generic. It's not specific to a particular type of sequence that we want to compare against another sequence, which means that if I want to come up with some test cases, I can compare integers or do different things that might be easier to compare, even though down the line I'm going to be using DNA sequences. Our scoring function is, again, a generic function. Our sequence is doing a type. The fact that type inference just sort of goes over this and makes sure everything works is great. So I define that alignment function. I can go in here, and if you look at the web page, they have their suggested weights to use for actual DNA sequences, so I can create something similar to that in F# and just turn it into a function for comparing. The result we get out of this alignment function is going to look a little gross naturally, you know, just the way I had it defined here, where it's telling you basically, okay, at this position, what's in the first sequence, what's in the second sequence, and that's an option, so it's either something, or none, which shows up as null, which is kind of hard to read. It's not quite as nice as the other things. So we can come in here and define just a nice pre-print function, so that when we try that again, we get results out in a readable format. And so you see that, okay, this whole chunk lines up with that whole chunk, which is probably pretty good. This bit lines up with that bit. We've got some gaps in here, but if you look at the penalties, then basically it makes sense to put the gaps there because the parts of the line are so highly favored. So again, nothing too groundbreaking, but doing it in C# would have been harder. So one thing that I showed you was, if you look at the align function, we've got options here that we're using. So if we're doing it in C#, we'd either have to use a type with null in it, or we would have to create some new type that we actually declare and make sure that we have the possibility to have null values or option none values or some things like that. You know, there are just so many things. Being able to write lists in a readable format and then convert it into a dictionary. And you know, later versions of C# always add more features to make things pretty convenient. But I think doing this in F#, what I found when I was doing this for the company that I was working for, doing it in F# was really invaluable. And again, the biggest benefit was I could do it in F# in a sort of naive way, get code that worked, and then when I built the C# code in a little bit more performant way, I could make sure that, okay, am I getting the correct output for this particular input? And is that the correct position? And so overall, I felt like the time that it took me to implement that was a lot lower than the time it would have taken me to just build a sophisticated C# version from scratch all in one go. I mean, you know, again, C# is not a horrible language. I think it's doable, but I really enjoy F#. I just want to very briefly talk about what's coming next. So in F# 3.0, some of you may know, there's going to be a new feature called type providers. And I see that as a very natural extension of what makes F# great right now. So right now, you know, as I've covered a lot, I think F# Interactive is a fantastic way to get a lot of stuff done. And I think it's great that you have type inference and that types really help you out. You know, if you look at the type of a function in your library, just from looking at it, you basically know how it's going to be implemented. You know, okay, what the arguments should be, things like that. And so you can use IntelliSense really conveniently. And I think that's terrific. But the issue that people run into is there's a lot of type data out there that's untyped from an F# perspective. So maybe you have a database and obviously the columns have some type, or you got a web service and different parts of the web service have certain, you know, types, or, you know, if you were to get the WSDL schema or whatever, there's a schema out there, but that schema is not represented in terms of F# type. And so at the moment, it's kind of a pain to interact with these things. You can do it. You're dealing with databases. You know, you can use link to SQL. You can compile that into a C# assembly. Like I said, the .NET Interop's great. Access that from F#. The issue that you have is you sort of lose this whole ability to just jump in and right away get started working with something. You know, I have a database out there I want to access, and I want to do that in 30 seconds. I don't want to go create a new C# project, link to SQL, add my tables to the designer, compile that into assembly, jump back to F#, reference that, and start playing around with it. And so that's really the big idea behind type providers. So a type provider is a uniform mechanism for presenting a typed interface over arbitrary data. And essentially what that comes down to is simulating .NET types and members where you don't necessarily have to create a real .NET type underlying that. And what that enables you to do is use whatever data you want in a strongly typed manner from F#, both F# Interactive and compiling things. Again, I don't want to get bogged down into too many details here. If you're interested, you know, Don Simon gave several great talks about what type providers are. But I do have a quick demo I can show you and how you reference a type provider. So building a type provider can be slightly involved because you have to figure out how should I represent all this information as types. Using a type provider is really easy. You just reference the DLL and you jump in and you get started. So I have a type provider that is just sort of an exercise playing around with the new version of the compiler. I built on my machine. And so I'll just really quickly show you sort of a toy example of what a type provider does. And hopefully from this toy example, you can extrapolate what it would be like to have type providers that do real work instead of just sort of the proof of concept type stuff that I'll show you. So I'm just going to create a new application. Doesn't matter. So what I did was I created a file system type provider. So what this is going to do is pretend that every file on my computer is a static type. They're nested within each other, and you can get the file name out as a static property. And it's not always useful, but it sort of is, because you can actually find out at compile time that the file that you're depending on is there. And so it's a very simple example, but it's not completely true. So I just have to find that. Of course, I close my solution. So I'm going to add a reference to my file system provider. But anyway, I only put that in there so that I could also access it from F-sharp Interactive, but it's not really important. So anyway, the point is, the great thing is you can IntelliSense. So here I have my C drive, and I can dive into that, and I don't care about my recycle bin. Let's see what we got here. We can look at the source code for the next version of F-sharp. And we can go in and look at, so here are some files. So all of these are showing up as if they're simulated types, and those people who don't notice the double backticks here mean I'm going to give you an identifier, but it's not a legal identifier, so I'm going to put it in double quotes. And so here I have a simulated static type of C:, F-sharp, VS Code, dev div, whatever.exe. And I look at the path property on that, which is a simulated .NET static field. That gives me the file name itself. And so if I run that in Interactive, it gives me the string result. So again, nothing, this is just a toy, but it shows you the type of thing you can do where you have data out there, and there's probably a better way to present it than is available using just the off-the-shelf .NET components. And it's really easy to create a little type provider that will show everything and make everything show up as types and give you really easy access to it within F-sharp Interactive and within compiled projects as well. So I think that's about all I had today. So for more information, here are some good links. There's a lot of stuff out there now at this point, which is great. So first of all, the F-sharp Developer Center at F-sharp.net, if you go there, it redirects to the MSDN landing page. Stack Overflow, if you have particular questions, you get stuck doing something on F-sharp, Stack Overflow is great. Visual F-sharp forums just were created recently, so this is sort of the official MSDN version. Definitely feel free to ask things there, but I think at the moment, Stack Overflow gets sort of more users on it. And finally, if you have particular things you want to contact me about, feel free to do so. Like I said, also bugs or feature requests, contact fsbugs@microsoft.com. I think that's it. So also, I'm happy to take questions on any of the stuff I talked about, or if you have questions about other things, or if after the talk you want to come over and ask about how to build a type provider to do whatever, we can play around on my laptop too.
So let's say you wanted to put F-sharp system that you wrote out on the web, I think web page server, let's say out of it. What would you need to do? I mean, certainly.
So it depends on what you want. So first of all, let me confess that I have not personally done anything regarding exposing F-sharp stuff as web applications. So, but I guess depending on how you wanted to do that, the easiest thing to do is build an ASP.NET MVC or whatever C# application that has the user interface stuff all in C# and that relies on an F# DLL to do all the tricky bits. So that would be one answer, but it depends on what you're trying to do. You can, I think you can do almost everything in pure F# if you want to, but it's not always transparent exactly how you
Would you need to bring along any kind of infrastructure to help the F# do its work, like an FSI.exe or something like that?
Well, if you're talking about, so are you talking about exposing F# Interactive as a website?
No.
So the F# core library is, I think, fsharp.core. That's really the runtime dependency that all F# code has. You can reference other DLLs, obviously, and you have to include those. If they're built in the framework, then they should be installed on the computer you're running on. So that DLL goes along with it. But if you build a project, an F# project in Visual Studio, it knows what all the dependencies are, and it will ensure that things get packaged up properly, basically.
Could you go to previous slide for a second?
Yeah. Yep.
Yeah, I had a question. When will that type providers be previewed? I want to play with it.
Right. So everyone wants to play with it. I totally understand where people are coming from. It's been delightful for me to be able to play with it, and I feel your pain, but I can't answer that, unfortunately. Let me put it this way. The team knows that people are really, really excited about this feature, and they want people to be able to play with it. At the same time, it's been undergoing a lot of changes as we see what works, what doesn't work, things like that. I'm not on the core development team, so I don't have any more information. I think if you, I don't have particular inside information about how progress is going or what form things will be released, etc. But I think you can probably think back to previous stuff that's been released by various teams and mentally picture. It would be pretty rare for a new version of the product to come out, and people have no time before it comes out to be able to play with it. So you can sort of figure out what the likely scenario is. I can't tell you when that stuff is going to be out right now. I wish I could. Yeah?
Is there any other feature that you would like to share? The new 3.0?
Well, that's the main thing that I've been playing with. I think, the team has been doing a lot of development on various stuff. I think that is the big new feature. I think that is a huge feature, and it's not like they're going to add 50 other things. I think you will find that lots of stuff has just been polished up from, IntelliSense, all the different, little bits and pieces here and there are all more enjoyable to use in the next version. But type provider is the big feature.
So wait, you can use an F-sharp type provider in C#?
No. So yeah, certainly not at the moment. So I think I can go into more depth about what type providers are if people are interested in that. If people have specific questions, maybe it would make more sense to talk to me offline afterwards. But the short answer is the F-sharp compiler runs your type provider to figure out what the simulated types are and how to convert those into stuff that it knows how to actually deal with at runtime. At the moment, there's no support for doing that from C#. However, if you look at other stuff that has come from the F-sharp team, if you look at the support for asynchronous programming built into F-sharp, if there are good ideas in F-sharp, a lot of times they will end up trickling down into C# at some later time. So hopefully that would be something that you can do. But the easiest thing to do would be build an F-sharp application, reference your F-sharp type provider. That will get compiled down to .NET code that then all the other languages can access. They're not going to be able to access the type provider directly, but they can access the results of what's been generated, basically, if that makes sense. Yeah.
You were saying that if you wanted to start getting really used to it, just sort of be like a little interactive running. Now, I've done that with Python and things like that. Do I have to start FS 2000, Visual Studio 2000?
No, I mean, I think that is what I would do, because you can have a script in there and then you get IntelliSense, you get all that great stuff. If that seems too heavyweight to you for whatever reason, you don't have to. So I think I believe F-sharp Interactive should be available
I've seen it exist as an exit. So.
Yeah, so you should be able to run fsi.exe or whatever it is and just get it as a console. I don't know what version of it yet. So yeah.
Complex project. There's actually a couple, I forget their names, but there's a couple of good ones. They're taking inside mixing, basically rehosting it into a pretty yeah, sort of similar. I mean,
there's also
it's definitely not IDE level, but it's something half a step up.
Another thing that's great is there's a website called tryfsharp.org, where you can actually run F-sharp in the browser. So this is a Silverlight application, but if you don't have F-sharp installed on your local computer and you don't want to for whatever reason, or I think this ought to work on even a Mac or something like that. Silverlight. Then
It'll work on that.
So
Silverlight installed.
Yeah. So you should be able to run this even if you don't have a Windows machine to install F-sharp on. But I guess F-sharp is open source and it's .NET, so if you had Mono, you could run it on other operating systems as well. But anyway, so you can come in here and say,
what's it called? Mono developer.
I was getting that mixed up. You can run F-sharp in your browser, and I think that's a great way to just sort of play around with it a little bit. And there are actually examples on here. There are things that you can do with the canvas, so there are ways to get little UI widgets and stuff even in your browser, but I haven't played around with that at all. But if you look, there are examples out there, and there are other sites. So Tomas Petricek created a site called fsnip.net. So here's a site where there's lots of little clips of F-sharp code that do different things. And if you click on a particularly interesting one, you can actually send these to try F-sharp, and it'll run it in your browser. So there are a lot of things you can do like that, where you know, if you just want to get a feel, and then it warns you because it doesn't know where the code's coming from. I don't know if this will do anything. But anyway, if you want to get a feel for the language, you can go to the FSNIP site, see if there are any cool examples out there, and then run in your browser. And again, I always use Google does, but yep.
How difficult is it to plumb up F# code to, say, user-defined functions in Excel? If you have
I have no idea. So in general, it's probably, well, either slightly easier or slightly harder than it is in C#, but I don't know.
It's actually near the same level of difficulty in terms of to make a choice between VSTO versus XLL, and then you're essentially going the full COM automation route, or you're going the attributes decoration route. It's one of those things where it winds up being, you know, in so much as it's just using the same mechanics of the .NET runtime and the CLR, it winds up being.
Yeah.
I was more thinking of it from the fact that, you know, Excel being a declarative functional language in some sense of the word, whether it was easy to translate
Yes, but
some of
that all gets lost in the COM OLE translation layer. So.
Implementation-wise, something.
Yeah, absolutely. I'm just saying there's not a. I think if you didn't have the COM, the normalization that COM provides, you would get almost a tighter parity between the two. But
You may look at what lookup element did. He just ported cool stuff from Excel.
Yeah, there's an XLL loop, and they've got more and more languages under it. You never know if they'll put that sharp under it.
So you can write Excel in F#.
But again, you know, even if it's sort of, there are ways to do that now that are a little awkward, maybe that's something where it makes sense to write a type provider, and then you could have a type provider that goes out, looks at an Excel spreadsheet, sees what different columns are, you know, smartly figures out what the data types in those columns are, and exposes that to your F# code in terms of properties on a type or something like that. So, you know, there may be ways to do that even more nicely in the future as well. But yeah, out of the box, I don't know. It sounds like it's not much easier than C#. Yep.
Yeah. There are some libraries like the Entity Framework and WCF where they use conventions that don't really work with F# out of the box, like, for example, F# records. Do you know if there's like any push to kind of support those things on one side or the other?
I don't know of anything specific. So what I would suggest is if you see limitations that are important to you to get resolved, definitely send an email to MSBugs, file an issue in Microsoft Connect online, which I think is the online bug database for things like Visual Studio. But you know, I think F# is a pretty young language. It's seeing a lot of very enthusiastic users, but it's obviously used a lot less than C# is. And I think naturally, people who are on the different teams are not always aware of what is going to work great, what isn't going to work great, and naturally the first thing you check is, does this work with C#? And so, I think some of them may be unaware of some of the little tricky things, and probably that's true from the F# side as well, where people have not tested out every library that's out there and seen, can exactly this thing work in F#. So if you see limitations, I'm sure everybody would be interested in getting them resolved. I think it's going to depend on the priorities of the different teams.
Okay.
Yep.
Just to get a taste of it, how much toy effort is to implement toy provider like.
So I'll show you. So that particular toy provider was extremely simple and is literally on the order of like 40 lines or so. So I guess there's two answers to that. So the one answer is the basic type provider API is quite raw and unpleasant to deal with, in my opinion. However, it's very easy to write a nicer wrapper around that. And so I'm using a wrapper called typeprovider.init. That is not necessarily something that's going to be released publicly, certainly in terms of the F# compiler itself, but it's something that will probably be made available as some sort of example or something like that. I don't know exactly what the release people for that would be. Even if it's not, it's easy. It's relatively easy to write a wrapper like this yourself. This wrapper is not itself all that involved, but I built this type provider on top of that wrapper. So if I had built it from scratch, it would have been kind of awkward. This abstracts away a lot of the pain points. So the type provider itself is, like I said, 41 lines here. So you at least in the pre-release bits that I've got, you mark your assembly as having type providers in it, so that way when you reference it, the compiler knows, look in here for type providers. You create a specific type provider is a type. So here's the file name provider type. You also attribute that, so the fsharp provider knows, the fsharp compiler knows, run through here to find types. So in the emit API, you've got this type provider for namespaces. So this is the namespace that we're going to use, and then under there we get the list of types that we want to synthesize. In this case, we're going through all the drives. For each drive, we check if it's ready. So if, for instance, I got a CD drive, I don't want to try to see what's in there and get weird errors. And then for each of the drives that is ready, we go through and we make a type, which is going to lie in the underlying namespace, and it's going to, as its path, have the root directory. And then we go up to this make type thing, then basically all that does is recursively goes through based on the parent and creates a new synthetic type somewhere. Provide type, this provide type method provides a type, and then we go through and in a lazy fashion we add all the files within that directory as subtypes, but that way it doesn't go through your whole hard drive when you first start out, it waits till you actually add it to it. Yeah.
Oh, okay. So you're lazily creating types. No?
Well, types in the .NET metadata, in the system.type sense. So they're all runtime. These are not. It's not generating physical compiled types. It's generating types which you can say, what are your members, blah 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 blah. They're not in a file on disk or anything like that.
It's only at a compile time that it will go through and it will.
So there are two different types of type providers. You can have ones that actually compile down into basically pull real types into your library that you're compiling, and there are other ones that are erased. And so what this one is just erased. So basically when we look at this path field, here's the value that's in there, and the types themselves just go away completely. There are no types being generated at all. And so what you can do is basically tell the compiler, when you see a reference to this method or this field or whatever on this type, here's what you should actually insert to do the work. And so that's what this is doing. So it's creating provided types, but those don't ever turn into actual .NET. But anyway, again, I don't want to get too bogged down into these details. All this is subject to change to some extent at least. But I did want to give you a feel for it. You know, it's pretty easy to get this stuff.
So now they behave like normal .NET types and reflection-wise. Those types generate.
I suspect that if you did a type of, it would give you the underlying type that you use. So again, there are lots of weird corner cases depending on what you're doing, and not all the details have been nailed down, so I don't think it's worth digging into quite that level of depth. But the big picture is, it's not that hard to create something like this. There are tons and tons of scenarios where it makes sense. Hopefully there will be people who are providing commercial type providers for databases that they run, or if you have a column store database or whatever, it would be great to see people providing type providers on top of that themselves rather than having you have to write your own one over it. But we'll see. I think it'll be interesting to see how everything develops. Yeah.
Currently, if you were going to add like in the current implementation, if you were to add like a function member, do you have to play around with stuff like expression trees, or can you just give it like a function?
So I don't even know offhand what the raw API looks like. This type provider emit API basically uses fsharp quotations. Okay. Usually, there are weird corner cases where that doesn't work if you're doing things with biref types or other stuff. But anyway, again, I think the main point is you can create a wrapper that does things in a nice way that takes fsharp quotations or expression trees or whatever you want to do, whatever makes sense to you, and you'll be able to do that and create your own type provider. Yeah.
Is there anything equivalent to Python's NumPy, the numerical Python?
There are a whole bunch of, so there's not an F-sharp specific one that I know about. There are a whole bunch of .NET numeric projects and DLLs and things. I don't know offhand what, I'm sure there are lots of people here who can say better than I could, how those compare to NumPy or what the benefits or disadvantages of the various different ones are. I think there are some where they even include examples in F-sharp, some are, were expected to be used mainly from C#, so they don't have any sort of accommodation to make a nicer F-sharp experience necessarily. My personal impression is that probably NumPy is a little bit more full-featured than most of the .NET numeric DLLs, but I don't know that for a fact, and if anybody in the audience has an opinion, I'd be happy to defer to someone
That's
else.
pretty good.
Yeah,
It's
for
good.
open source one, Math.net. There's several commercial ones that are very full-featured and robust and SquareSharp, but of course they're commercial, so.
Right.
But yeah, for an open source one, Math.net is probably the most full-featured one that's out there at the moment. But yeah, I would say I don't know NumPy well enough to say that's on par with that, but it is for a numerical mathematical library, very complete. So. And F-sharp friendly.
Any other questions? Okay, thank you, everybody.